So hey everyone, welcome back to Placements Ready. In this video, we will be solving the problem binary tree to BST, which has been asked in today's problem of the day. But if you are new to the channel, please do consider subscribing. So let's read the problem statement out. So we are given a binary tree, convert it to binary search tree in such a way that keeps the original structure of binary tree intact. For example, here 1, 2, 3 is the binary tree. Now we need to convert it into a BST. And what is a BST? In BST, the left node should be having a value lesser than the root node and the right node should be having a value greater than the root node. Okay. So for example, if you see here, 2 is having a value lesser than 3 and 2 is having a value greater than 1. Okay. Or you can say like 1 is having a value lesser than 2. So in this way we have converted this binary tree into BS. So I hope you have understood the problem. Let's discuss how we can do this. So here let's say my binary tree is like this. Okay. First of all, the in order traversal for a BST is sorted. Okay. So what we can do, we can have a in order traversal for this. How we do the in order traversal? First of all, we call the in order function or the recursive function on the left node. Okay. So our in order function is like this. So first of all, it will be called on the left half. Okay. And we will pass a v also, which will store the in order traversal of the tree. Now when we go on to the root, what we do, we push back roots value or data inside the vector v, and we can have in order root arrow right. So in this way we can travel the tree in an in order fashion and we can store the nodes. So what the in order traversal will look like here, it will first of all go on to this. It will, since there is no left child, there is no right child. Okay. And when we go on to this, it will store 2. Okay. Now it will return back. Since the work for left child is over, we will be storing 1. And now we go on to the right child. Since there is no left child for this, we go back, we store 3. There is no right child, we store nothing. Okay. And we will be having 3 here. Okay. So in this way, we have the in order traversal. Now what we can do, we can sort it. 1, 2, 3. Okay. So our sorted vector will look like this. Now what we can do, first of all, we will be making a utility function. The utility function will be, what it will be doing, it will be taking the middle of this. Okay, we can start a uh, we we can pass the start and end to the utility function. Okay, first of all, calculate the middle. So it's similar like a binary search kind of thing. So it will be calculating the middle, it will get the middle. Okay, now it can make a new node. So node star root equal to new node with the value v of mid. Okay. So our root node is made. Okay. Now we can call the recursion on the left subpart, on the right subpart. Okay. So for example, we can call the recursion on the left subpart. So basically the work of this function is that we will be making the binary tree to BST. So now root arrow left will be called on the left subpart. So we will be passing the start, and now the end will be mid minus 1, because in binary search also the left part is going to be mid minus 1. Okay. And the right child will be nothing but root arrow right is equal to mid plus 1 to end. Okay. So this is going to be the right subpart, and in the end we can return our root. So in this way our function will look like. Okay. Now let's do a dry run how it will behave. So let's say my my in order traversal is like this. Okay. First of all, what it does, it creates a 2. Okay. It creates on the recursion on the left subpart. The recursion will make this. Now there is no left child, there is no right child. How it will be decided? If my start crosses end. Okay, then we can simply return. So it will return from here, it will return from here, because here start and end is going to be 0. Okay, since we have done the work, we will call on the left. Okay, so what will happen, start will be 0 only for left and end will be -1, so we can simply return here. So from the right we will return, and when we call on the right, start will be on and end will be 0. So here also we can return. Now this will be stored in the roots left, and when we are done with this, we can return to the parent. Similarly, we can call the recursion on this. Okay, for this my start is going to be 2 and is end is going to be 2. Now we can make this thing, okay, roots right with this node, and we can simply return. Okay, and in the end we can return this 2 to my parent, or to the function that has called it. So I hope you have understood the problem. Now what will be the time complexity for this problem? Basically, we have the in-order traversal first of all. Okay, so in-order traversal takes order of n time. Now we will be sorting it, so that is going to be taking a n log n time. Okay, and basically making that function, recursive function, will take a order of n time. So overall we can say that the time complexity is going to be n log n. Okay, and the space complexity is also going to be order of n, because we are using a recursive stack space. First of all, for the in order traversal, which is order of n, we are using a vector which is also order of n time, and in the end the recursive stack space for the recursive function is going to be order of n. So overall it is going to be order of n. So this is going to be the space complexity for this problem, and this is going to be the time complexity. So I hope you have understood the problem, how we can do. So first of all, what you will be doing, you will be having a tree. You will calculate the in order traversal for that tree. You will be sorting it. With the help of sorting, I know like the elements before the mid element is going to be smaller, so I can consider these elements as a left subtree, and the elements appearing after the middle elements, I know that is going to be the greater with the middle element, so that can be the part of my right subtree. So sorting will help in doing that, and then the recursive function. Okay, so रिकर्सिव फंक्शन में पहला स्टेप क्या है, बेस केस. ठीक है, कि स्टार्ट हमारा एंड से ज़्यादा हो गया, मीन्स वी हैव एक्सीडेड द बाउंड्री, वी डोंट नीड टू डू एनीथिंग. आफ्टर दैट वी विल कैलकुलेट द मिड एंड मेक द रूट. ठीक है, तो 2 1 3 था, इसको सॉर्ट करा हमने, 1 2 3 बना, 2 से हमने मिड कैलकुलेट करके रूट बना लिया. नाउ वी विल कॉल द रिकर्सिव फंक्शन फॉर द लेफ्ट हाफ, वी विल कॉल द रिकर्सिव फंक्शन फॉर द राइट हाफ. ठीक है, तो रूट लेफ्ट में स्टार्ट को स्टार्ट से पास कर दो, और एंड विल बी नथिंग बट मिड -1, एंड रूट्स राइट को पास कर दो, स्टार्ट +1 एंड मिड. ठीक है, and finally we can return our root. So I hope you have understood the problem. Let's discuss the implementation. So here, if you observe, if my root is going to be null, I can simply return a null. That is the base case in every tree problem. Okay, now the vector int v, why we have taken it, we will be storing the in order traversal in that vector v. So we have called the in order, passing the root and v. Okay, and here if you observe, this is my in order function, it accepts a root and a vector v. Okay, and the vector has been passed by reference. Okay, so that will help me to save the time as well as space. uh, if my root is going to be null, I can simply return. Now if that is not the case, we will call the in order on the left subpart, passing v. If we are at the root, we will be pushing back the roots data into my vector, and otherwise we will be calling it on the right subpart. Okay, now we can simply sort it, sort v dot begin, v dot end, and we have initialized our root to null. Okay, and we will call the bst util function, passing the vector v, uh, start pointer and end pointer. Okay, so start will be at 0 and end will be at v dot size -1. What this function is doing, basically if start is greater than end, means we have crossed the boundary, we can return a null. Otherwise we will be calculating the mid. Mid will be nothing but start plus end by 2. We will be making the new node, which is node star root is equal to new node, and we will be passing v of mid into it. Roots left will be equal to BST util vs mid minus 1. Okay, basically the start will be start itself, and the end will be mid minus 1. The roots right will be called on the right subpart. So start will be mid plus 1 and end will be end itself, and we can return a root. Okay, when we get it, we will assign that to the root and we can simply return the root. So I hope you have understood the problem. Let's discuss some interesting problem in another problem of the day video, and do check out the graph playlist. The link for that is in the description, and if you haven't subscribed our channel yet, do consider subscribing. We are making regular videos on tutorials. So that's it for this video guys. Thanks for watching.